Testing. How do I know if this is working? I have no idea to know if this is working. Hey! Whoa! Cool, okay. Okay, nice. Okay, I was just looking at the stream in the other window. Cool, 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 cool. Cool, 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 cool. Base. Okay, so what are we doing today? I'll show you. Hopefully you can see the stream. So, yesterday I got the UI system patched up. You can see a video I posted earlier on it. But we got the playback system. We got scrolling through the UI. Let's just click on one of the contacts to inspect it. So, as you can see, we have this whole cool UI system showing off this little physics system in the background, but you know, it's totally fixed. I can't adjust the camera. There's no concept of a camera. I'm just drawing to a screen with a fixed min and a max, and I can't adjust where we're looking, and I can't zoom in. And so what I want to do is I want to be able to fix that and kind of treat the screen like a little mouse I can move around and zoom in on. And I already have a lot of code fixed in place determining like what the screen coordinates are, where we are in world space, so it'll be kind of difficult to adjust that. And so that's what we're going to do now before it gets even harder to do. So to that end, I've specified, well, like in all my drawing code, I've specified like a camera position, but it's just 0, 0 for now. So what I need to do next is just start feeding in those camera coordinates to every single drawing function in the software renderer. So I guess we'll just get started on that. Let me just look up the camera pause stuff. I think I set it to, yeah. So I set it to 0 every frame, so I need to tuck it into the game state. Right now it's not really organized that well. Yeah, camera pause. Okay, let's go to where we init everything in game init. Let's just specify game state. Camera pause. Set it to 0. So now we should probably get a bunch of errors. Yeah, camera pause, undeclared identifier. So now we need to do, what is this doing? There's just a bunch of random code everywhere that I was creating to get this all set up. Oh yeah, I'm subtracting the camera position. Okay, so instead I just need to attach game state camera pause. And we're just going to do that to every single variable, every single instance of the camera pause name. Recompile it, see where we are. Okay, so let's see if anything has failed catastrophically. Okay, we're still good. Perfect. So now I'm just going to draw some text telling me what the camera coordinates are, just so I can have a little visualization of that, if you will. And I'll tuck it somewhere like here. Screen, camera. Yeah. Make it print some F's. Screen, camera, pause.x, screen, camera, pause.y. Where are we going to put the Y start? I don't know, I'll just like put it somewhere in the middle of the screen. And we'll see what happens. Okay, perfect. So, you can see we're displaying the camera coordinates right now, and when I hold the middle mouse wheel and move around, you can see that the coordinates adjust. So like I'm dragging it down and you can see the camera. Okay. Not really sure how I want this to work. Screen, camera, pause. I think I want to add it. I want to add the difference in the Y mouse coordinates when we drag the mouse. And just as a little test, I'll set the game state camera pause.x equals the screen camera pause dot x divided by the pixels per meter, which is just 32. Just as a simple little test. And we'll see how this catastrophically breaks later. Nothing is happening. Let's also print the actual camera position. The world space camera coordinates, if you will. Let's just call it world camera. Do camera pause. I'm just doing the bare minimum, simplest stuff first. And once I can see it works, then I'll abstract it, pull it out into another struct, make some function calls for it. But until then, we're just in the raw testing phase. Ah, okay, so you can see. Interesting. Okay, so we can move the shapes around when we scroll. That's amazing. That definitely tells us that something is working. And now we just need to apply this to the lines that we draw and the contact positions. Basically anything in world space that we want to depict. Like the UI is fine. The UI can remain as it is. We don't want that to shift when we adjust where the world space camera is. That's cool. Can we do better though? I don't even know if this is accurate. We like shift it all back. Oh god, please. Let's see. Interesting. Don't really know what to think of this at the moment. I guess we'll just get the rest of the primitive software rendered shapes moving with the camera. The lines and the contact points. Where do we draw the lines? Let's just look up all the draw line routines. Just trying to find. This is where we draw the capsule. Okay, so just as a little bit of explanation. All the entities that we've created, every single frame, we loop through all of them and just draw them for that frame. A game engine is basically just a big loop, and you loop over all the data every frame. You clear the frame buffer at the start, And then every single frame you loop through everything, and then you draw it all again. So that's what we're doing here, and we have a little switch statement which selects, depending on the entity that we have, if it's a circle, if it's a capsule, if it's a triangle, or a square, like an oriented bounding box or an axis-aligned bounding box. We have a different routine to draw that specific shape to world space. So right here, we're drawing the capsule, and you can see I'm giving it the camera position, and then we get the screen position. And I want to see if drawing the circles correctly. You remember what the dots on the capsule look like. So you can see on this capsule, like when I light it up, you can't really, but there's dots on the end points of it. And when I shift the camera around, those dots aren't overlapping with the line, but we do draw that line at the center of the capsule correctly. A capsule is just a line segment with a radius all the way around it. It's like how a circle is a single dot. Like I can put this dot in the center of the circle. We just fill in all the pixels in a certain radius around that dot. The capsule is the same concept, but it's like a dot that's extruded in a certain direction. And we fill in all the pixels that are within a radius of any point of that line. That's what the capsule is right here. Oh, cool. I can still rotate it. That's crazy. That's wild. So the position that we need to click on to even grab the entity is also offset. Wow. We need to fix all this stuff. Lots to fix. So we'll start with drawing those dots. Are those contact points? I think those might be potential contact points. Draw all potential contact points. Let's just skip this routine for now. I can hot reload it. I don't know why I keep shutting it down. Okay. It is interesting. Oh yeah, that makes sense. Because like those dots that we were drawing on the capsule, we're drawing the closest possible contact point for every single shape, including the lines that make up the walls. So I can just go back to drawing it, and I close the engine again. Of course. So you can see, you just pause it right here. These dots on at the beginning and end of that capsule. One of those dots is the closest contact point to the line up top. The other one is the closest contact point to the line on the bottom. And we can resume playback and it'll flop over. And you can see that now the closest contact points are to the left and the right. So we just need to draw those contact points relative to the camera offset, which we will do right now. I have a whole 2-screen routine. We'll just do that. 2-screen. We'll feed in the point, the camera position, the pixels per meter. That's what ppm is, pixels per meter. And then the frame buffer height. Yeah, it's really verbose. I can always shrink it down later, but that's not really a concern at the moment. So now, yes, we are drawing all the points relative to the camera offsets. So that's nice. Now we need to draw the lines. And there's one dot over here. Oh, I think that's like this resolution 0, like this highlighted text. I'm just drawing that dot over there as a visualization of like the hinge point that all this text rotates around. So that's not. Ignore that one. So I need to find where I draw all the static geometry. All those lines are separate from all the entities I draw. Can't remember where I do it. Might do it up here. Oh yeah. Yeah, I do it up here. I feed them. So this is really inconsistent, but I have this concept of draw commands where I attach them all to a buffer and then I execute all those draw commands. But I've been inconsistent, and instead I've just been executing draw commands as they come. I can organize all this later, of course. I've just been kind of lazy and inconsistent with it. I think when I'm submitting this command, the PO and the P1, those are in screen coordinates. So, yeah, we'll just do this. To screen. I'll feed in the original point. I'll feed in the camera position. Feed in the PPM and the frame buffer height. Right here. I don't want to type all that out. I could make it smaller. Whatever. Okay. Now let's see. Okay, well the lines are invisible. Hey, that's perfect. That's definitely not what we wanted. Oh, that's because I was feeding in P0 to P1. Still invisible. Look at that. Did I not compile it in time? Still invisible. Okay, perfect. Ah, yes. Okay. Oops. I just need to feed in the P0 and the P1 and not that draw command stuff. Okay, perfect. Now we can see the lines and they move. Amazing. Truly. Can we draw? No, we cannot drag them yet. So the next step is to... Oh, that's so cool. That's so cool, dude. Okay. So we can't drag them. I can demonstrate why. Those shapes still have an absolute position. So like we offset this to the center. And if I remember correctly, like you see how the mouse is in the bottom left of the screen. And when it's intersecting where it thinks the capsule is, you see the capsule light up. And I can drag it like that, right? That's definitely not what we want. The way to fix that is I have like these different blocks of loops where I iterate through the entities before I do physics, and then I do physics on them. Like I update the velocity, the position, I check for contacts, and I resolve them, and then I draw the entities. We have like three basic things. We do the pre-step where we check for mouse intersection and dragging on the entities. We run physics on the entities, and then we draw them. So up at the top, where I check for mouse intersections with the entities, that's where I want to calculate their positions relative to the camera position. This would be so much harder in 3D. I would need a cast array and go through a little voxel grid. This is so much faster. I love it. But first I need to find that routine where I actually determine where the entities are, and I think it should be right here. Yeah, so we loop through. This is like the pre-entity step where we do the mouse picking loop, where depending on where the mouse is on any given frame, we're going to intersect that with, well, basically we just loop over every single entity. We don't do any acceleration structure. We just go, hey, is the mouse intersecting this entity? And we can just go through a list of 1,000 entities potentially, and for each one check if the mouse is intersecting it. So it can definitely be slower when we have more entities, but at this moment in time, we only have 2 entities. That's totally fine. I'm not worried about performance right now. Just want to get this thing working. So, we just care about the circle for now. Let's go here. Mouse world. Yeah, okay, so I think I need to do... So we feed in the mouse world space coordinates, and those will absolutely be influenced by the camera offset. So, where does that come from? Mouse world. We'll probably just offset it right at the start with the camera coordinates. Mouse world B. That can't be right. Where do I find it? Yeah, right there. Okay. Oh. I don't think I want to do that. Okay. And then we'll do mouse world minus equals game state camera pause. I should probably check. I should do that after we scroll or adjust the camera position. .x. Yeah, okay. It's right after here. Yes. That's where I offset the mouse position. And so, I'll offset a little bit, and it doesn't work. Hey, look at that. Wow. Maybe I need to add it. I don't know. I can never remember what to do. Still doesn't work. Okay. Interesting. You can see our line stops drawing. Our left line stops drawing. Huh. Oh. It's because it goes out of frame and we just stop drawing in the entire routine. So I need to fix that. There's lots of things I need to fix. Let's fix that right now. I think it's in draw line. Can I just continue? Or if it's less than 0 or y is less than 0, we break. I can just continue. Yeah. Just continue in that case. And we might have entered an infinite loop. Yeah, okay, so that just takes us into an infinite loop. Because I guess we never increment x0 or y0. Oh well, I'll figure it out later. It's not a big deal. That's a consequence of software rendering. You gotta make sure everything is perfect, and a lot of the time I don't have the mental bandwidth to solve everything. But that's fine. We only care about intersecting the entity positions. Let me get some water. What's my lid for this thing? Oh yeah. Perfect. So we were adding something to the mouse world coordinates. World mouse? Oh, this is the wrong file. Okay. Okay. Just print out the mouse world coordinates too. Okay. And I overlapped that text on itself. Oops. Okay. This is definitely not right. The scaling is off that I apply. Somehow. Shouldn't even adjust that much, right? Just trying to conceptualize the problem we're facing right here. Hmm. Divide by the pixels per meter, right here. Just call that ppm. Do I need to invert it? That can't be right. That definitely can't be accurate. I used to be able to draw a grid. Where did it go? Grid. Does it still work? Yeah, cool. Okay. So, we're drawing a grid. And each one of these cells is one unit in world space, right? So I'll shift the camera, what should be approximately one cell up, right? And now we're seeing that the world camera reads positive 30. And that definitely can't be right. So the screen camera is also wrong. That's only like 32 pixels that we moved. Tricky. It's just some scaling problem, and I can't think through it clearly right now. But that's what you're here for. You're just here for me to stare blankly at the screen and ramble incoherently about it. You can look up the scaling. Yeah, like let me just pull up the calculator. Let's pull up Speed Crunch. We'll go 969 divided by 32. I mean, of course, that'll give us 30.2. But there's no way I move that much. Like, let's move... You see how I move the mouse around, where like coordinates 200y right now, and then down here it's like coordinates 400. So let's just move 200 pixels up. Screen camera just... What the hell? Oh, it's getting cut off because I'm not giving it enough space in that little printing routine. That would be nice. I'll just give it like 48 characters. In sprintf, we just don't give it enough space to print out all the characters it actually needs. Okay, so now let's just scroll like 200 units, which should be like down here. I'll just mark it where my finger is on the screen. We'll scroll that much. And that is 200 pixels that we moved the camera, so that is accurate. Man, I can't understand this. So, when I'm moving the mouse around like this, the top coordinates are where the mouse pointer is in world space, and the bottom coordinates are where we are in screen space. So you can see I just move one cell across, and that is 32 pixels. Why is this not translating correctly into world space? Oh. I think I know one of the problems leading to the confusion in our drawing routines. When we do that two-screen routine, let's find the first one. Let's see what it does. The camera position. Ah, yes. Okay, so we're treating the camera position as if it were world space, when really we want it to be in screen space. Camera position in screen space. I guess we can subtract it from the world pause immediately. So we do world pause minus equals the camera pause, and we'll see what that does. Okay. Hey, okay, that's already better. Yes. I mean, some things are thrown off and it's all backwards. It's all inverted. But it's definitely scaling or scrolling faster like we wanted it to, like almost syncing up with how the mouse moves. So that's great. We're getting closer. I really need to figure out that line drawing algorithm. Man, if it starts before we hit the frame buffer, then it just doesn't draw at all. But let's not dwell on that. Problem is that we are, I think we can add the camera position. Yes, since it's in world space, before we were subtracting it because that was just what we do with screen space, but now, yeah, so at least the x coordinate matches up how we move the mouse, but the y is still inverted. Mouse world plus equals. Okay. Yes. Yes. Just collapse all this down into mouse world plus equals camera pause. Just add a little note. It's totally I mean, we have screen camera pause, and I'll just call it world camera pause. Let's change all instances of that to world camera pause. Hey, it's still inverted. Yay, look at that. I think we do want to subtract it. Does it even make a difference? Okay. How do we even want it to move when we scroll the camera? I think we want to invert it. Because like I drag it down. Do I want the... It's just really up to my own quality of life. Like, how do I expect it to move when I drag the mouse? Do I want the controls to be inverted so when I pull the screen to the bottom left, do I want to move everything to the top right? You know, because right now I'm dragging it to the bottom left and everything in the world follows, except for that circle. That circle is definitely off. I guess I should also draw the grid or change how the grid moves. That would be interesting. One thing at a time. I guess it doesn't make a difference how I... Mouse world minus equals world camera pause. Why doesn't that change anything? Oh well. Okay. Do I like this? Yeah, no, I'll just I'll drag in the direction that I want things to move. So I can click down here. Okay, so like, if you imagine like, oh, I have all this stuff down here, I'll put the mouse there and then I'll drag it to where I want it to be. That's a bit smoother. And hey, you can see that I can accurately click the entity now. That's cool. And now it flew out. Oops, it's gone forever. Okay. Okay. Now we just need to change that circle thing. RB circle. Screen pause. Get screen pause. Okay. That's nice. Wow, that's freaky. Let's do a replay. Okay, so it falls off, and then that's when I pick up the circle and I throw it. I throw the capsule too. They bounce off each other and then they get sucked in. That's crazy. Let's click on that contact. Damn. There's just so much stuff that I'm drawing. Holy shit. With the grid. Yeah, I need to disable the grid now. It's so hard to read any of this with that grid. I just want to find the relative velocity. You can see it right here. Damn, 56. Okay. Well, anyway, we can move around the little world space thing, and that's great. So next, I want to add scaling or zooming. And that's going to be trickier. Kind of. I think we'll do it after we composite everything. We'll draw everything to the standard frame buffer, and then based on the scale value, we'll shrink or expand the entire thing. If that makes any sense. But then that'll prove difficult, like, ah, man. It really depends on what we want to do, because let's say that we draw some stuff off screen, and we composite the whole screen. All the stuff that's off the screen gets cut off, and then if we zoom out, you'll see like black borders on the side where we couldn't draw that stuff. Oh well, I guess we'll just do the most straightforward approach, which means just cutting off all that stuff, and then we'll see how we can adjust it later. Let's add a little scale value. Float, camera scale. I don't know. Go to game init. We'll just do game state camera scale equals 0. Then we'll go to the input struct. So like f input mouse wheel. Mouse left. Mouse middle. Mouse wheel, okay. We'll adjust the scale by the wheel. Also do plus equals divided by ppm. I'll just convert that to a float. And then we'll also draw that screen just to make sure that everything matches my mental model. If I can find all those routines where I draw all that text. Oh boy. Okay, here we go. Just clutter up with some more text, why don't we? Let's call it mouse scale. I'll just print out one float. We'll just see what happens. State mouse scale. Did I not call it the right thing? Camera scale. Oh, yeah, good camera scale. Okay. Oh, it's because I saw mouse world, and I'm like, oh, okay, now we're doing mouse scale. Like, that makes any sense. And I need to draw it to the right place. Just draw it above everything else. Okay, so you can see right here, camera scale, and I'm scrolling the mouse, and we are in fact adjusting the scale, so that's perfect. So, what does that even mean? Like, of course we'll start with, oh, I see, I just want it to be 1. I need to initialize it to 1. Don't set it to 1. Don't set it to 0. I'll set it to 1. And then when we adjust it, I'll just check. If it's less than 0, what does it even mean if the camera scale is 0? That's way too small. This is tough. I'll just cap it at like a quarter, right? And then we'll just set it equal to a quarter if it's way under that. And we'll just cap the zoom to like 4. So we can scale a factor of 4, either zooming in or zooming out. And we'll just test that real quick. Okay, so camera scale starts at 4. Oh, oops. If it's greater than, if it's greater than 4, we'll set it to 4. If it's less than 0.25, we'll set it to 0.25. Okay. Okay. So you can see the camera scale right here. I'll zoom in. It stays at 4. I'm still scrolling the wheel. It stays there. I'll scroll all the way down. It stays at 0.25 even though I'm scrolling past it. Okay, perfect. So now we need to write a basic routine that takes the entire composited frame buffer, like at the end of every frame, and like zoom in to wherever the camera is centered. And I think that will be tricky. It won't be that bad. I'm gonna take a quick 5-minute break. No comments, no chat. Cool. Cool, okay. See you in 5 minutes, 3 minutes, 2 minutes, 0 minutes. Roommate is in the bathroom. Man, the pains of living in a shared house. If I spent like $3,000 a month, I would be able to get my own bathroom now. Imagine that. Oh well. 2 people are watching right now. Damn, that must be me. That must just be me. Okay, I'm just watching 2 times. Not bad. Cool. Okay, so let's look at the, what do we want to do? The scaling. Okay, so I have an old scaling routine somewhere down here. Drawing the mouse cursor. This is drawing the performance stuff. Yes, this is where I scale. So I can just copy this. And we'll remember how we scale everything. I think this is inside the fixed update loop. Drawing all the text. Drawing the mouse cursor, drawing the performance timer. I don't think we'll do that after we scale everything. This is going to be tricky. This is going to look really, really sloppy, and I'll need to refine it and do some techniques that I can't remember off the top of my head. Whatever, we'll just see what happens. So let's just drop that scaling routine in here. We'll need another temporary buffer. Oh well. We'll just need a whole nother frame buffer, and I think I can provide that. How do we even get pixels in the first place? So we allocate website. Where do we allocate all these pixels? We'll just need to, I think the way I want to do this is that we have a huge 2-dimensional array of all the pixels that we're drawing to. And if I want to scale them, I need to loop over that entire array, and based on the scale, I need to copy every single pixel and either scale it up to occupy multiple pixels or shrink it down. Yeah. What do I even set pixels to? Do pixels equal something? Yeah. Bitmap memory size. I'll just call it scaled pixels. Why not? Who knows? That's a lot of memory. Oh well. Let's call it scaled pixels. We got nothing to lose. We're experimenting. And then we set pixels to the frame buffer. Frame buffer equals pixels. We'll do that to scaled pixels too. Let's call it scaled frame buffer. Equals scaled pixels. Okay. Lots of errors. Because they never added a semicolon. And it's titled the wrong thing. Okay. Scaled frame buffer is not a member. I thought it was. It's not a member of game memory. What is it then? Game memory.scaled frame buffer should be a member. I'm confusing myself. Why am I getting this error? It's in the struct. You can click on it. You just look up every instance of frame buffer here. Platform. I also have a website or like a browser version of the build, so I can build to Windows or the browser, and I'm compiling to it with Clang, but these aren't Clang errors, they just appear to be the regular Windows errors. Scaled frame buffer. What the hell? I'm just totally stumped by this. This is rather embarrassing. It happens. It's been a long day. Been slinging my resume around. I'm like, oh, I could use some intellectual peers. Let me apply to some jobs or some residencies. And of course, I just get rejected by everything. And so I've been reading through those, and I've still been working, so it's been a rather exhausting day. It's not a member of game memory. What the hell is happening? Better find it right there. It's right there. Like, I don't know, test. We'll see if this gives us an error. Game memory test. Did I call it the wrong thing? Scaled frame buffer. Tested on member of game memory. Okay, it's because I commented it out. Scaled frame buffer should be a member. That's weird. It's working now. Did I not save it? That's really weird. Can't believe that just derailed everything, and I think it was just a problem with not scaling it. Oh my god. Whatever. Let me see where I do the memset on the pixels. Memset frame buffer. Oh god. Okay. I'll do like mem copy. And then we'll copy the scaled frame buffer into it. Yeah. We also need to make that a member. Scaled frame buffer. In state, I think we just set this every frame equals, yeah. We'll just do scaled frame buffer. I do not know what you're doing, but I am interested. Cache save data, bro. Your stream top popped up as the first recommendation when I opened YouTube. Damn. Shit. Okay, sorry guys. I wasn't looking at the chat for a while. How do I even articulate what I'm doing? What I've been doing so far is... okay, shit, I broke it. Okay, that's because I'm not putting anything into the scaled frame buffer. Let me just comment out all this code. Let me, 0. Sorry, let me just comment out all this experimental scaling code. Okay, so, yeah, it looks like a mess, but what I'm doing is I'm working on a 2D physics engine, and I was trying to, like, it's just fixed to this area of the screen, but, you know, I'm trying to debug all these contacts so I can step through the time, and you can see, like, it's going to be hard for you to see. But when I mouse over one of those red dots, that's a contact point between entities, and it'll show me all this data about that contact point and those entities and me trying to push them apart. But I was thinking, man, it would be great if I could drag this little box, drag this little world space around the screen to get a better view of what's going on. And so that's what I was working on for the past hour. So I can hold the mouse wheel, and we can drag this around so I can place it anywhere on the screen. And the next step that I want to work on is, oh, if only I could scale this up, like make that little world space occupy the entirety of the screen. And so that's what I'm working on now. And so we have a two-dimensional grid of all the pixels that I'm drawing to. This is software rendered. So every single frame I determine what I want to draw, and then I calculate where those pixels would be to the screen, and then I light up those pixels. And so the really rudimentary method of scaling up the world space that we're seeing right now is I just create an entire copy of the frame buffer, and I loop over every single pixel, and then depending on the scale value, I either make that pixel occupy more pixels or I shrink it down, and that's what we're going to work on right now. I think I should just keep the scale at, camera scale. This is the wrong file. Camera scale. Yep. Okay, I'll just cap it to 1. If it goes beneath 1, we'll cap it at 1. And I only want the scale in right now, or zoom in right now. And so we're going to write that very rudimentary zoom routine down here. We have the temporary pixels. This was something old where when I was first working on the software renderer back in July, I just wanted to take a little 64 by 64 subsection of the grid and then expand it or scale it up. And so I need to remember how I was doing that exactly. And this is going to be tricky. Scale difference. I haven't done this in a while. But the idea is that I have this temporary buffer to the side that I want to copy all the pixels into. I want to loop over every single pixel in the regular frame buffer and copy them into the other one. Yeah, okay, I think I know what to do. I think it's going to be a huge pain. Let me do memset. Okay. I've already lost where we were. So we're going to copy over all the pixels. We're going to clear the original buffer. And then we're going to loop over every single pixel. Oh man, this is just going to scale everything. But we got to do the simplest possible thing first to verify if our mental model is correct. Warning, this stream. What about this stream? Oops. Open Studio. Getting some warning about this stream. Oh well. OBS is telling me some warning about the stream. Sounds like the things in my spiritual life. This is cool. I was on Flight Simulator earlier and my rolling cache was set to 0. I tried to move it up and the game kept crashing. I don't think I've ever played Flight Simulator. But that sucks that it keeps crashing. I don't think I'm caching any save data right now. I then went to Profile Save Data and reset default. Then was able to move the rolling cache to 100 gigabytes. Oh yeah. Yeah, I think what I'm doing right now is I don't have any cache thing like that set up. All I have is I just allocate like 2 gigabytes of RAM as soon as the application starts, and that's all the memory that I can work with. If I wanted to have like 100 gigabytes of cache, that's more than I would have RAM. I would need to do some kind of fancy Windows paging with that, but I don't know how to do that yet. But yeah, nothing fancy like Flight Simulator. This is a really rudimentary software renderer that we're writing a physics engine with. So we're going to copy over everything to the scaled frame buffer. Scaled frame buffer from the regular frame buffer. And we're going to clear out the original frame buffer. And if this is right, then everything is just going to be black. And it's probably going to chug performance too. I ran it before I successfully finished compiling. Okay, yeah, perfect. Okay, that's exactly what we want to see, a black screen. Is that anything to do with what you're doing? I'm not tech savvy. No, don't worry. I don't think, yeah, definitely not. Flight Simulator is much more advanced than what I'm doing. I'm just writing a very basic software renderer, and I'm stacking a physics engine on top of it. Any caching that I do, or I don't even know how to articulate it. I just allocate 2 gigabytes of the RAM up front. That's the entire cache that I have access to. I can't expand it. I can't shrink it. Like, sorry, I'm not doing a very good job at articulating this, but I can just show you where I allocate the memory. I do. This is the application. This is the entry point for my application, and I allocate 1.5 gigabytes. I can type in like 2. I'll just show you what happens. I'll just type in 100 gigabytes that I want to allocate, and we'll crash. We'll just crash immediately because that's more RAM than we have access to on this computer, right? So I would need to do some fancy Windows stuff to get anything more. But we don't really need anything more. 1 gigabyte is much more than anything we need. So anyway, we're worrying about scaling. So we copy over all the pixels, and now we want to loop over every single pixel. Scale difference is, man, I can't remember what this is. Whatever. Let's just write a brand new loop. Let's just wipe everything. Okay. I think like we should see everything again. Oh yeah. Just recompiling it, running it. Okay, so we're going through a few extra steps. And now, let me just, okay. We're definitely chugging harder. I think performance is taking a hit because now what we're doing is we're copying over all the pixels multiple times and clearing out different caches. I guess the coding on your screen that says game memory made me think I was in the ballpark. Yeah, like kind of. But instead of doing flight simulator stuff, we're just directly editing the 1 gigabyte that we've allocated in the game memory, but not doing anything like caching, like, oh, we need to increase the cache or else the game will start crashing. That's not our problem right now. We're just trying to visualize all the data correctly. So let's just start looping through everything. For int, let's just call it x equals 0. X is less than game state, frame buffer width, x plus plus or plus plus x. Then we'll do that for y2. Or no, I think we want y on the outside. It doesn't really matter. We'll do this for x. And so depending on the scale, let's do scale equals game state world scale. So what we want to do, I guess I should draw this out with Paint. Microsoft Paint. I don't have a tablet to draw on, but yeah. So we have this frame buffer. This is the width. I'll just call it W. This is the height. And this is a pixel grid. So just imagine that it's a bunch of pixels on a grid, right? And so we want to loop over every single one. And they can have a color in them or not. And depending on the scale, man, this is challenging. I've never done something like this before. So we want to copy all of this over into another frame buffer. I'd like to learn, but I do not think that I'd be able to survive actual school of this. Haha, more like a hobby. Yeah, school. I went to school for this, actually. Well, not really. I went to school for computer engineering, and that was mostly circuitry. Yeah, cool. Okay. So I went to school for circuitry, computer engineering, and it basically taught me nothing, and I don't even use the degree anymore. And if you want to actually learn how to do this stuff, it's very simple. And I'll just show you right here, Handmade Hero. And so there's this guy, Casey Muratori, and he made 600 episodes starting from scratch, how to write your own game engine. I'll just show you. I don't know if you can hear my audio. I have my audio muted. But you want to go to, I'll just drop it in the chat. Here's where you want to go if you want to start learning to do what I'm doing. But if you can learn to teach this, then you'll be even better, so train yourself how to teach it. Yeah, exactly. Teaching it would be a good idea. I've been told that I would probably make a good teacher. And I do have a basic structure set up where I could teach how to get this set up. Maybe in a month or a few weeks, or I don't know, because it will take a long time, because I'll need to like clean up the code, I'll need to sort it, I'll need to start making all these videos explaining what you need to do and how to set up your environment. But if you want to teach yourself right now, then start watching Handmade Hero and see what he does, and then like talk to ChatGPT, like how do I, like, you know, ChatGPT is basically just a fast Google search, and it can tell you how you would set up a window in the Windows API. A window being something like this, a thing that you can click and drag around, and then you can access the pixels, and then you can start drawing pixels into it. So let's go back to scaling. So can I copy and paste? Let me like select all this. I'll copy it. Okay. Okay, cool. Can I? Okay, perfect. Let me just select this and paste it. So I'll just paste another arrow. Yeah. Okay, so we want to take, so we're looping through every single pixel in this grid, right? And we're taking this pixel over here, like the 0, 0 pixel, and depending on the scale, we want it to occupy these 2 pixels next to it. And so we like fill in these 2 pixels over here. If the scale was 2, for example. If the scale was 4, then we go like 1, 2, 3, 4, make it occupy even more space. So, this is going to be tricky. And this is going to be really horrible. This is going to be awful. But I might as well get something working. And we'll just make it an integer. World scale is not a member of game state. What is it then? Oh, camera scale. I keep confusing the names, the variable names. Is the scale or the zoom of the camera? Maybe I should just change it from camera scale to camera zoom. Maybe that's for the best. Yeah, I'll just call it zoom. Okay, better, even better. So we copy all the memory. I don't even know if we need to memcopy it first. You loop over every single pixel, and I'll just call it like a pixel, U32 pixel equals game state, frame buffer, and then we do y plus or y times. Yeah, so this is just a little trick that you essentially need to memorize to loop over pixels in a grid. And I can explain it. I guess I can explain it, why not? I'll suck at it. But we do y times the width plus x, and what that is doing is, imagine if, I'll just, I like clear all this. New file, please. New, don't save it. So we have a little grid. This is our grid. And let's say that it's a 4x4. It's a little 4x4 grid. And so, where's my paintbrush? Brushes. Let's say y equals 4. That's the, well, no. The width of this canvas is 4. And the height of this canvas is 4. And if we loop over everything, we'll start at like x equals 0, y equals 0. And this is a collapsed one-dimensional array. And so to iterate over every single pixel, we'll do y times width plus x. And so what this does is that, let's say that we want to start at this pixel. That means y is 0 and x is 0. So 0 times w plus 0 equals 0, right? That is the 0th index, the 0th pixel in the array. So now we step over into this one where x equals 1 and y is equal to 0. So that means 0 times w plus 1 equals the first pixel, or the 0th pixel in the array, and then the first pixel in the array. Remember, you start with 0 indexing in computer science. And so we can do that for every subsequent pixel in this row, 2, 3, and that still works out. The math still works out. 0 times width plus 2 or plus 3 equals 2 or 3. And so let's say that y is 1 down here. Y is 1. Y is 2. Let's go to like the second row. So now you do 2 times w plus 0 if we're looking at this cell. X equals 0, y equals 2. 2 times w is the same as 2 times 4. Remember, the width is 4, which is 8. So if we number all these pixels, this is 0th pixel, first pixel, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11. And so we did the math for this pixel in this grid, and we got, it's the 8th pixel. That's what this little calculation is doing. Y times the width plus x. You're just iterating over a flat buffer. It's treating a flat buffer as a 2-dimensional array, And this is just one of the math equations you can use to index into it. So that's all we're doing. And so we're looping over every single pixel. And now we somehow want to translate this. We want to scale up these pixels in the neighboring frame buffer. And that is where this gets tricky. And very, very sloppy. Because I've done scaling before, but not like the entire frame buffer trying to scale up. I'm trying to think this through. It's going to be very slow. I'm trying to think it through. I can't quite grasp it in my head. We have the zoom factor. Let me just try and draw it out again. I wish I had some kind of tablet. I can draw it and paint it on the side, but you won't be able to see it. I have this little touch screen over here. 1 second, people. Can I change what monitor we're looking at? I don't think so. Oh well. Let's go to a new file and we'll draw another grid. Let's just try and get the simplest possible mental model working of how we want to scale this thing. Let's just call it a 4x4 grid. And so we want to take this so we have this grid right here. This pixel right here in this grid. This is x is 0, y is 0. God, drawing with the mouse is horrible. And so if the scale is 2, then we want to fill in these pixels right here. And I guess we're starting from the top right. This is brutal. This isn't going to look clean at all. I think I have an idea of what to do. It's not going to be pretty. But we'll just go based on the scale. Let's just lock the zoom to 2. To 2 for right now. Zoom equals 2. We also want to consider how we're going to step through this. So we take this pixel, we paste it over here, and then if we take this next pixel, then we'll just paste it right there. And that'll start overlapping pixels. So that will not be good. So instead we want to step 2 pixels every time we paste something. So this is like pixel 1. And this will be the area of pixel 1, and then this will be pixel 2 right here. Then 3, and then 4, and then 3, 4, and those go over here. 5 will take up this space. 6 will take up this space, right? Man, I need to get. If I'm gonna stream more, I need to get a drawing tablet. So for every single pixel that we take over here, we're going to fill in 4 pixels. Assuming the zoom is a factor of 2, we'll do scaled frame buffer. y plus 1. Do we want to do y plus 1 or y times 2 plus 1? Do equals pixel. We'll do that 4 times, right? But now we need to be careful with how exactly we step through and paste into the scaled pixel buffer, scaled frame buffer. Let's look at Microsoft Paint again. This is 1, and 1 will take up 0 and 1. 2 will take up 2 and 3. 3 will take up 4 and 5. Let's do a new one. Gonna take a lot of drawing this out. And then we'll do an even finer frame buffer over here. This will have 8 pixels. Okay. So we'll take pixel 0. This will be the space of pixel 0. We'll take pixel 1, go here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So we're scaling up every pixel by a factor of 2, and this is what it would look like in the buffer that we shift or scale or paste everything over into. And so let's keep the indexing, so 0, 1, 2, 3, 4. I'll give them a different color. Let's make it green. 0, 1, 2, 3, 4, 5, 6, 7. For y, and I don't know, we'll give like x. 0, 1, 2, 3, 4, 5, 6, 7. So for the 0th pixel that we want to copy over, we're filling in pixels x and y. Let's make a little table. Or am I doing this right? I don't know how to visualize this. 0. We want to fill in pixel 0, 0. X is 1, 0. 0, 1, 1, 1, just for the first pixel. And then for the second pixel, this is 0, 1, 2. We want to do 2, 0. 3, 0. 2, 1. 3, 1. We're trying to come up with some algorithm to know exactly where to paste the scaled pixel coordinates. 1 times 2 plus 1. I think I'm getting it. This is y over here is 0, 1. What happens when we're pasting 4 in? We're doing times 2. Okay, I think I understand what we're doing. We're multiplying y by 2. We're multiplying x by 2. And then we're strategically incrementing it by 1 or 0. 0, 0, 1, 1. Okay. Yes. Okay. I think this is what we want to do So we loop over the frame buffer, we paste it into the scaled frame buffer, and then we copy all that memory back over. And so I think this should work. It'll scale everything up. Oh my god, that looks absolutely horrible, and it is not what we wanted. Interesting. Yeah, we lost all our viewers. Oh well. Oh well. Trying to see if I can fill the whole thing to white. That's not working. Ah, of course. If y times 2 is greater or equal to frame buffer height, continue we'll do that for x2. Okay. That's the region that we're scaling up. Interesting. Very interesting. Oh, well, whatever. I'm gonna take a little break. I'll be back in 1 minute. Okay. Okay. We want to center this region. Depending on the camera position, we have this big white box, and that is half of the size of the frame buffer. And this is the region in which we'll be sampling the pixels from and pasting them into the larger buffer and then copying them back over, right? So we want to center this where the world space is. We just disable this code. This is a huge joke. Oh God. Hello, new viewer. I'm trying to figure out how to scale up stuff. I'm trying to figure out how to zoom the camera. And it's been a long day and my mind is starting to fail me. But we're almost there. We're doing the simplest possible thing where we have a bunch of pixels and we just want to scale it up by 2. I'm trying to conceptualize how we're going to do that. Let's just draw and see what we have. We should see a big white rectangle somewhere on the screen when we boot it up. Okay, it's better than nothing. Now I guess we'll do screen camera pause plus this. Screen camera pause dot x and y. Those are the coordinates where the camera is. Make it game state. Store it in the game state. Perfect. Okay. Interesting. I'm trying to shift where we want to start. I'm trying to shift the region where we want to take the pixels and then copy them over into the scaled up frame buffer. We're getting there. We can at least move, shrink, expand the zoom area around. To start Y, 255. Okay. 5, that should be 256. 1. Confusing myself. It's going to take a while to figure out this whole scaling thing. All I want is the simplest possible case, and I'll call it there and sleep on it and figure out how to make it more robust. And the simplest possible case is to figure out how to scale all the pixels in a selected region times 2. And so right now we're trying to figure out that exact region based on this arbitrary concept of the camera position and the frame buffer width and height. Should add these to the debugger over here. Yes. Four concurrent viewers, my God. 2 of those people are me. 2 of those people aren't me. And 2 of those people are going to be very upset because this is not entertaining in the slightest. Oh well. Zero, max Y. We should be drawing a big white box. It's kind of a big white box. Can we make it larger? Yeah. Make it larger like that. This white box that's shrinking and growing is the area of the frame buffer that we want to copy the pixels from. And of course it's not working. I want to, you see where this capsule is, the circle is, I want to put it directly over where these things are. Damn, that shot off. What happened? I just want to inspect the physics debugger to figure out why the capsule just flew off randomly. Bear with me. Oh, I see. Okay. Yeah. Yeah, the my impulse solver is broken. So the circle just falls on top of the capsule, and the engine is like, oh, okay, the relative velocity, we just need to fucking launch the capsule into space. That's how we resolve this collision. So that's partly the reason why I want to zoom in on things, to get a closer look at exactly what's happening. There it goes. Bye. Oh man. Crazy. That's funny. I love this snapshot system that I made. But that's not what we're trying to do right now. We're trying to figure out how to copy pixels over. And we're failing miserably. What is the max Y in this case? Ah. Yes. Still not right. Okay. Getting there. Just constraining the region from which we want to zoom in. Ah. That's freaky. So it's based on the screen camera position. That is quite freaky. Screen camera is 0, close to 0. Myself. That's where start Y needs to be. Okay. Move it down, sure. That's fine. But now it starts to shrink. We don't want that. Camera. So I want to start at 0 over here. Where do we want the sample from? Let's say Y sample equals Y plus start Y. And X sample is X plus start X. And we'll also check if that's out of range. X sample is greater than the width. Y sample is greater than the height. Y sample, keep saying scample. Y sample and X sample. Okay. Okay. Closer. It's kind of tracking the screen. Okay. Hey. Oh my god. Dude. It works. It's awesome. Kind of. Oh god. Oh Jesus. Okay, so we got zooming. Hey, we got zooming. It's totally broken. It's busted, but it kind of works. But this is probably not how we want to do it long term. So I need to figure out what to do next. Maybe we just need to scale up how we draw everything depending on the zoom. Leave all the text drawing the same. I don't think this is the way we want to do things long term. This was just a little exercise and it kind of works, but there's a lot more to be done and a lot more thinking to do. So I think I'll leave it here. Hey, thanks for let's go. Yeah, we got woohoo, we got scaling working, thank God. But it's broken. After putting in this past half hour work on zooming, I don't think this is the way we want to do things long term. So I'm gonna stop streaming for now. I'm gonna eat dinner. Could you render the game in large chunks and just zoom in? That's kind of what I'm doing. I can disable this whole zoom thing right here. I don't know if that'll break anything. What happens if we do that? Okay, so this is without zooming. And we zoom in, and we just zoom in on this little region of the frame that scales everything up. So I guess I am... I'm just rendering it in one chunk, and then if you... I can just draw a big white frame. Big white rectangle over what we're actually sampling from. I'll just show you. I'll comment out this thing. So this big white rectangle is the thing that we're sampling from. That's just the game world. I just zoom in onto the game world. I don't adjust where the mouse is based on that. Can I like pick up one of the entities? Yeah. Yeah. Oh god, it fell out. Okay. Could you render the game in large chunks and just zoom in? How do I answer that? I'm rendering it as one big frame buffer, one big chunk, and from that single big chunk I'm selecting a region that I want to zoom in on. But I'm not adjusting where the mouse world space is or anything like that. It kind of fucks up all the rendering because I also zoom in on the UI. So I think instead what I want to do is in every single routine in the software renderer, I input the zoom or the scale amount that I want the camera to have, and then depending on that I just adjust the drawing routine to scale up whatever shape I'm drawing, and I leave the UI untouched by that. So I think I need to do a lot more plumbing to get accurate scaling working. Instead of just after I draw everything, I scale up this little region. If that makes any sense. But I'll need to do some experimenting with it later. I need to take a break anyway. I need to stop streaming. But there's a lot of different ways I could scale it. And as a test, I picked the simplest one. And the results from that test are that this is not the way to progress to do zooming in my little engine. So I need to experiment with other methods. And I'll do those in the coming days. I think I understand now, yeah. As you stream more development, I'll understand more of what is going on too. Thank you, exactly. So, it's going to take a while. I can't articulate it now. I don't even understand the problem space fully. I guess I'll make a little devlog about this later. That would be a good idea. But for now, I gotta go. I'm tired. I can't really talk right anymore anyway. But thank you so much, John DZ6QXQ, for joining. I really appreciate it. But I'll see you later. Thanks for tuning in. Bye-bye.